Hello, and thank you for joining me for the coding section of our applying functions, our fourth class of our data basics, wrapping it up. You're all data scientists now. This is a really good base, and I think you'll find learning to use pandas, really learning to play with data so much easier from having learned Python in this format. Okay? So we're going to go over two types of functions, the user-defined functions like we talked about in class, and then the lambda functions. We're just going to highlight what they are. We're not going to spend a lot of time on those, and then we'll really show you how we commonly use define. Okay, so here what we're going to do is, so we're going to define a function. Again, we use the word def, we name the function, and then we can put a variable inside of our function or many variables that we'll be passing and then using. So this x value is what we're going to then use inside of our functions to be used during the operation of our function. Okay. And then we're going to finish it very important with these colons, just like if, for, and defining a function are all the same in that sense. And then also very important, special to a function is that we're going to return what happens inside your function doesn't really get saved anywhere. It kind of disappears after it's happened. So anything that you want to save and you want to be able to use again, which is quite often the reason you use a function to be able to use the result. And here you need to make sure you're returning that result. So it's going to come out of the function. You're able to use it in a different way. So run this out, define this, or initialize this function called multiply by 2. So we're not going to do anything. We're going to take x in, and then we're going to multiply it by 2. We're going to assign that to result, and then we're going to return the result. So if we use this function down below, we're going to see multiplied by 2. We're going to give it the number 4, and we're going to, so if we give it a number, let's say 49, just because we get a 90. So we're able to repeat this over again, or we're able to multiply this again, but we're able to use this as many times as we wanted. And if I wanted to say do this again, I could do 50. I wanted to reuse this function again. Okay, and that's kind of the idea. Multiplying by 2 maybe isn't the most commonly used situation, but you'll be able to repeat your tasks over and over. So you can return multiple outputs. The way we do this, so just again taking in the variable, defining the function. Result 1 is x times 2, just like up above. Result 2 is I'm going to take that result 1 and then divide it by 8. We have result 1 and result 2. So notice here that I have two results here. Okay, so result 1 and result 2. I'm then going to assign result 1 and result 2. So this is defined based on position. Whatever I assign, I'm going to be putting in the first position of what comes out of my function. It will be in the first place when I'm assigning the outputs of a function. So this answer 1 is going to be the same as result 1. I don't need to call it the same, but it's based on the position that I set that they're going to come out. Okay, and so I'm going to print here answer 1 and then answer 2 just to highlight. Probably, I think I mentioned this already, but the way a colab works is you're not actually going to be able to see this. It's just displaying what's in the last line. So I had to print out the answer if I wanted to see both of them, because you won't see the first one if you don't print it out. Ask Python to actually display it. This is just a feature of a colab notebook or a colab or a Jupyter notebook. They just display the last line. So just something simple, but know that we're not saving these variables, just displaying them. So defining another function, we're going to take two variables this time. So we're going to go this times that, a times b, and then we're going to go a times b, go c, and then we're going to return c. So just like I was saying, we are seeing the output of a function, but we're not actually saving this number anywhere. If we wanted to save this number in some place, I would have to actually assign it to an output here, so C, and now I'm able to use it again. Yeah, I could call it whatever I want. It doesn't have to be the letter C. I could say D. Let's be creative and D. Okay, so you can call it whatever you want, but it comes out of the function. Okay. So this divided by, or divide by that. Okay, so I'm going to take A and B. I'm going to assign these two arguments though. So A is my argument and this is equal to 2. B is going to be equal to 1. So I'm not just defining these on position like I did up above. So this is in the first position, second position, and what I do with the first position is A, and then what I do with the second position is B. So here we're actually assigning them arguments of A and B. So we can do that, so we don't need to actually call them in an argument because these are the default values. So if we don't reassign them anything, they're going to be A and B. Okay, so we just call the function like this. If you can also define them in position. We define A in one, or sorry, A in position 1 and B in position 2, 0 and 1. And so if I wanted to do them A and B, I could just by default use A and B right here. It's going to be 1 in position A and then divided by 2. So you can see you get 1, 5. Here what we're going to do is we're going to go A equals to 2, B equals to 1. And so you can see here, it's going to be the same as the R output. We could say through here. It's going to use it like it's in the position where it's going to use this as if it were A. It doesn't need to be in the same position though. So we can put A down here and B up here. Let's just change B to 4. And you see you get 4, 1 divided by 4, right? So B is going to be the one that's divided by, but it's being taken in the first position, but I'm assigning the default argument. So the way it works when you're using functions from other libraries, which we commonly do, you might know like the first positional argument, the way to assign it just based on position. You probably will become familiar with the first one, but it is kind of a safe bet after that you're going to want to call and assign specific arguments. You might not know the position by default, and it probably will not be something that you spend a lot of time. So talking about a doc string right here. So doc strings are a way to communicate your coding, what really happened inside your function, what's going to be happening inside your function. This is using more complex functions than just this, but it's good just to kind of note what you're doing. Okay? So string is 1, and then I'm going to take string 1 and string 2, and I'm going to just add them together with a space in the middle, and I'm going to make a join string 1 and string 2. Line in front of it. So it's me defining the function, I'm going to be returning that join string, and then I'm going to do underscore, which is 2 underscores, doc underscore, which is 2 more underscores. Kind of a really computer sciencey thing. But this is going to give me the doc string. So because I defined my doc string in 3 comment signs, Python knows that this is now the doc string, and then it will say when I use .doc, it will pull out the doc string. Okay? You can also do just a question mark after the string. Notice I'm not putting any parentheses here. Just asking, what is the doc string here with 1 question mark? Or if I did 2, it's going to give me the full string. So here it just shows you the doc string up above with 1 question mark, and then if you have 2 question marks, it shows you the full operation. You can see all the functions you're using, all machine learning models. You can see exactly how they work and stuff like that if you're curious in learning about the mathematics. Okay, so functions and lists. So list of numbers. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and then big numbers. So I have a list of numbers, and what I'm going to do is I'm going to put up this function, add 42 to the number, put this inside the function. So I'm going to put my blank list of numbers, which I'll be filling up, which is a very common workflow that we saw. We start with a blank list that we'll be filling up before n in list of numbers. So in this list of numbers, list of numbers 2 dot append add 42. So quick and easy. Now I have a list of numbers that are 42 greater than the list of numbers that I had before. Not super valuable, but again, you can see how this will be able to automate, simple things, correcting mistakes, correcting little things, but having little customized things. Add 42. There's no default function that's going to add 42, so it's not really that different, but slight differences. Things that are not common. Find the mean, find the median. What if I wanted to find the 25th percentile or something? This is a little bit different. That you can make your own custom function. So here, I left the code just to show how you would import this data from your Google Drive. If you want to run this, then you have to give it access, just kind of clicking accept. Google standard kind of allow process if you want to give it access to your drive so they can pull in the data, or you could just use the data that I have in my GitHub reservoir. Okay. So as long as you have an internet connection, this should work. And if you're watching this video, you probably do have an internet connection. Okay, so we're importing our dinosaur data set, and again, I worked very hard on this. Please, have fun exploring it. Time travel, tricky thing. Anyways, so here I create a df.shape, and I get 1,000 rows, 4 columns. Okay. So if I wanted to just plot a histogram, this creates tall, medium, and short. So I'm going to use a histogram just to kind of understand tall, medium, and short. And you can see you have 3 kind of natural spacings for this. And we'll cover histograms and distributions a lot in our data analysis classes. Okay. So we're going to define a function right here. We're going to call it height buckets. And so what we're going to do is we're going to use this with dot apply. And when I use with dot apply, this x value is going to be the value in the row. So going to be iterating through the rows, and every time it gets to the row, every row is going to be dot apply is going to be passing a value in the first position of our function, which is usually what we define as x, and we're just going to pass it to this, and dot apply is going to take care of the passing of the function. Okay. And so here we're going, if x is greater less than 0.7, we'll say low, we'll do a value equals to low, and then we'll go else if it's greater than 12, we'll do value equals to high, else value equal to medium. Okay. And so run this function, see what happens. So then we're going to apply this one, we're going to dot apply. Notice I'm not putting the parentheses around this function, after this function. We're not using the function. We use a function, we put parentheses, like I'm using dot apply here, so I put parentheses after it. I use df.head and put parentheses after it to look at the head. If I don't put parentheses, I don't get an error, but this is called referencing the function. So you don't get an error because you do need to do this sometimes, but you're obviously not getting the output that you're expecting. And so the reason being is in this situation, I'm referencing height buckets. I'm referencing this function I made up here, but I'm not actually specifically using it at this instant when I'm writing it right here. Dot apply is going to be passing that the x value. Let's see what happens after I run this. So what I will do, I want to see the value count, so the count of each value in the heights category. Okay. And I got an empty series. Well, that's probably not good. So I forgot something very important, right? We have a function. As I said before, everything disappears in the function we use. We have to return the values. Let's try this again. So we're going to return now this value. We say short, tall, and medium. And then we're going to apply this to the function. Let's see what that is. Now we have these values. Okay. So let's just do another example with anomaly type detection. So just kind of highlighting some anomalies. So I'm going to plot the seaborn plot. I have my, just to quickly show, we'll go over seaborn in a lot more detail, but sns.scatterplot. So I'm calling the seaborn library as I assign the alias sns scatterplot. Data equals df, so I'm giving it access to my full data frame. So I can just give the column title x, y, and x and y, these two values, so tail length, teeth size. I'm going to call this hue argument. This is a really fantastic functionality of Seaborn that we have this hue argument. So hue equals to height category, the height category that we just made. And we're going to go tall, medium, and short. And it's going to define these in different little places right there. Okay. And so you can see here we have our palette as well, as you can set the colors. Should not be the default, just to okay. So what we're going to do is we're going to define this. You notice there's some values here that don't really seem to fit. They seem kind of like outliers and stuff like that. So let's highlight them as anomalies, and so we can just highlight those specific events. So what we're going to do is we're going to be taking in two categories this time. Okay, so we're going to say if the category, so in position 1, so we're getting x, and x is going to be the row. It's not going to be one value. It's going to be this whole row. So in position 1 of x is going to be height. In position 2 is going to be t size. So we're going to go if x equals to medium, position 0, which is height category, with anomaly, then we're going to say value equals to anomaly. Else is normal, and then else is normal. And in either situation, what we're going to be doing, sorry, I should actually say this, if x is less than 10, which is kind of less than 10, so it'll be one of these values. It's medium, but it's less than 10 t size, which is kind of weird, right? So we can see here value anomaly. So we're going to go if it's medium in position 1, and then if it's less than 10 in position 2, which is t size, we're going to go it's an anomaly. Okay, so we'll do that right here, and then we'll do and we can see we have 17 anomalous kind of features right here. I'm going to join these strings to show another purpose right here. So now I want to join the height category with the anomaly category, so I can plot these 4 different types of categories that I've now created. We will do this. So I create the string just like I did above, a slight change to the above. And we're going to join, we're going to be taking the string, doesn't have to be called x, but apply is going to be passing one thing to this in the first position. It's going to be s plus a space plus the second value, which is going to be the anomaly here, normal. So let's run this, and you see now we got 4 values: tall, short, normal, medium, anomaly, our 17 values. So now if we plot this in a scatter plot, you can see here now we have highlighted these medium anomaly or these red. Okay? This gives us a lot of flexibility. This is a fantastic way to kind of highlight certain things you want to do in your plot, really assist in your analysis, do lots of flexibility, but it was very handy in machine learning and stuff. So this is just a really powerful technique, and it's a great practice with functions and using them in more complex ways. It's a good kind of stepping stone to use them kind of with training wheels and with .apply. Okay, so have fun and have fun exploring the dinosaur data set. Talk to you next time.